Welcome. Thanks for joining us for our live stream. We'll get started here in just a minute. Anne, do you need the link or are you good?
I think I'm good. I'm going to, if the Patreon's the one that
There we've got. All right, well, welcome. I've got a quick question before we get started, Darren. So Robert says, looking to transfer propane from one tank into my Super C. What is the name of the fixture you used on the video that made it simple to do? And we'll have a couple links we'll put in as well for those, but you can kind of talk a little bit about that and we'll put the links.
Okay, we could add links maybe to that video, but there's a couple companies that make these things. One of them is called Extend to Stay, one's called a Stay Longer, Sturgis Stay. But if you, I do believe on our Amazon affiliate store, we've got some of that. I'm not exactly sure what category those are under. But anyway, there's manufacturers that make these adapters that go, so here's your AMSE tank, and then you have your service valve. And then you just disconnect. It's a left-handed thread. You move that out and you put that in place and you connect it. It's a really simple operation as long as you have enough room to move in there. Sometimes we do get into situations where the space is kind of tight. But for links, there's several different manufacturers. Some of them you're going to find have a quick disconnect. Some of them you have to have a tool to put it on. So they give you several options there. So we'll make links to those at the description of this video when we publish it.
Yeah, and there's links in the chat right now, so you can get them right
now,
there.
If you really want to be technical, there is a way to transfer it from, like if you have two DOT barbecue cylinders, there is a way to transfer it from a tank to a tank without any of this. You do need to have some devices for that. If you want to know more information on how to do that procedure, the NFPA 1192 Chapter 5 does have a section in it on how to transfer propane from one tank to another tank. I'm not going to get into that here. I've not done it myself, but the information is in there. If you really want to get the propane out of one tank to another tank, it's in the NFPA 1192. Walks you through the procedure on how to do that.
All right, so we're going to have you ask your questions. Thanks for joining us. We're going to answer your questions live. And so if you haven't joined us before, we do this every month, the first Friday of every month at 4:30 p.m. Pacific time. We go live and you all bring your troubleshooting questions and we ask them to Darren and he answers them.
Try to.
So in the chat, you can go ahead and start putting your questions in. We'll get to as many as we can. We have about an hour. And when you are putting in your problem, go ahead and include the manufacturer and the model number of the device that you're talking about. So for example, Suburban, you could say it's a Suburban SF30 for a furnace, or a Lippert, in-wall slide out, or a Dometic RM2882, something like that, Let us know the specific manufacturer model of the appliance that you're talking about. Before you hit post, if you can just kind of quickly skim over, check the spelling. That's not because we're English majors, it's just because autocorrect can do some funny things and make it really confusing. And then you are limited to characters, so even though it is helpful to have things be succinct, if you need to use more than one chat, you can go ahead and copy paste and make it longer by doing 2 or 3 chats. So I have one more pre-queued question, and then we'll start taking them from the live stream.
I've just got to laugh because like a year or two ago, you would have not had any clue what you just said about the SF35. You would have I have no idea what that was. Now you're just rattling it off.
It's amazing the things that you pick up just over time because, Sid and I mean, we're not RVers, and so, we didn't know anything when we started out, and I still don't know anything, but there's some stuff that you pick up on.
Yeah.
Okay, so Ashraf and Celine sent us an email. They have a Dometic RM2652.
Okay.
And they have a couple questions, but we're just going to ask this one right now.
Okay.
So he says, if the thermistor regulates the refrigerator part by sensing coldness from the freezer, hence why one slides it up and down the fins, then what is regulating the freezer part and how cold it gets?
Okay. So you're talking about the absorption refrigerator in your RV. The way I want to clean up some of the understanding of how they presented it and how they understand it. So there is no temperature sensing of the freezer compartment. The temperature sensing is done on the fins of the refrigerator. Different manufacturers have it different ways. Some of your Norcolds, it's the 10th fin over. Some of the Dometics, it's going to be all the way on the right-hand side. You can slide it up and down. But what that's doing is it's not sensing temperature, it's a thermistor. So it's a resistor that's changing its resistance value based off of temperature. And so the control board is seeing a value of resistance change. On the Dometics, you're looking for around 8,000 ohms, ballpark, you know. So go to our website. You could pull up, we have a lot of refrigerator manuals on our website. Under the manuals, just go to resources, find manuals, find your refrigerator, and in those service manuals, you'll find the thermistor value for yours. But Dometics overwhelmingly shoot for 8,000 ohms. So on these refrigerators, we just did a cooling unit replacement just yesterday, as a matter of fact. But so I'll just draw something, and maybe this will help. So on your freezer, if you were to take your refrigerator out and lay it down face down on the floor, what you're looking at is a big metal assembly. Okay, that's the cooling unit assembly. It's full of ammonia, hydrogen, distilled water, and an anti-rust inhibitor. Because ammonia is these cooling units is the story of ammonia, and but ammonia is very corrosive to steel, so they have to keep that in check by adding a sodium chromate, which is an anti-rust inhibitor. But anyway, so on your freezer, the back of your freezer, if you were to rip the back cooling unit off, you're going to have this zigzaggy thing, okay, that's going to come down like this, and then it's going to go like this, and then it's going to drop down to the tank, okay? So what we have here is this is your freezer compartment, and what we have here is this is your refrigerator compartment. And so this is the tubes that you can't see unless you rip the cooling unit off, but this is where all those little refrigerator fins are, okay? And so the thermistor that you're talking about, I'll change the color to red here, is basically moving up and down here. And so you're moving the temperature resistance device, the thermistor, the resistor that changes its resistance value based off of temperature, either closer to this tube or closer to that tube, okay? And so that's what you're adjusting. Now, it's one loop that's flowing through this. Up here, you have your high pressure vessel. This is your low pressure. So basically, it's the coldest part. Up here, it's minus 22 up in this area, okay? And where does that come from? That's what happens when ammonia vaporizes. It vaporizes and goes from a liquid to a vapor. It's an exothermic reaction. It becomes minus 22 degrees, and they vaporize that into a hydrogen environment, which acts as like a multiplier, okay? And so it's minus 22 at this point. And so we're basically going to be monitoring the temperature of this flow here where it's about to exit and go down into your absorber vessel. And so by monitoring the temperature of the fluid where it's exiting, that's how we adjust it through the whole process. I'm idling because I want to get to more questions, but so let me just focus on it. I could spend an hour on this, so let me just try to lay my plane on here. So on your refrigerators, you're checking the temperature between the two loops that go through the fins, okay? You're either closer to the loop or farther away, okay? And so what you're looking for is it comes in and loops and goes back out. And so what they're wanting to know is what's the temperature here at the refrigerator, and what they're shooting for, oh, this thing just came apart, 8,000 ohms on a Dometic. Okay, well, there's that problem. 8,000 ohms on a Dometic equals around 37 to 40 degrees is what you're shooting for. 37 to 40 degrees is your target here. So by raising or lowering this thermistor, you're going to read the temperature of this tube coming back from the freezer. And so the temperature of the freezer is a function of the temperature of the refrigerator thermistor. Okay, so let me just go with that. And believe me, I can go on for another 2 hours on these things. They're fascinating. But that's what's going on when you're adjusting your refrigerator thermistor. You're moving it closer or farther away from the tube coming back. And then the very last thing it does is it goes back to the absorber vessel. And I'm going to stop there because I could go on for another. So, okay?
All right. Okay, so Ralph, yes, I believe I have your question queued up. I'll make sure that we address that, and I'll give some shout outs here. So we've got Wanda tuning in from Georgia.
Hey.
We've got Troy from Arizona.
Yeah.
SRQ guitar guy. Hey, we have an SRQ.
Yay.
Sarasota, Florida. Brian in Virginia. Ralph in Florida, Ray in Utah,
Outstanding. Good deal.
John in Idaho, and Bruce locally, Auburn.
Hey, all right.
Over in Auburn. Okay, and so
Welcome.
before we go to our first live question, I do want to let you all know about our Patreon. If you've not already joined us over on Patreon, it's pretty cool over there. It's kind of its own private community. And we have 3 different tiers on there, $5, $15, and $25 tier. And we have lots of content that we post on there. We have a series called Growing Your Mobile RV Repair Business. Right now we post weekly episodes of that. We also do Zoom calls with our RV Tech tiers. That's the $25 a month tiers. We do those twice monthly. And so we also have archives of all of that content. And so if you were to join today at the $15 or $25 level, you would have access to I think we have 9 episodes in our growing series, and we have about, I think 21, we have archived Zoom calls. And on those Zoom calls, we used to just do them kind of open format, kind of like this, a little more focused in on the RV tech side of things, so business incorporated with troubleshooting type of things. But we've actually switched over to more topical. So now our Zoom calls are almost more like a webinar where we're focusing on one topic and we go through that and then we answer any questions at the end of it. So lots of great content over on Patreon, $5, $15, and $25 tiers. If you just want to be the first to know when we release something, you can join over there for free, or you can check out the benefits at each of those. So we'll include a link there. After we're done with this live stream, we're actually going to go over to Patreon. We do an exclusive live stream there right afterwards. So hope to see you on there. And so our first live question, Brian says, I have an Atwood furnace, AFMD 30121, that I'm working on. Everything checks out good, but it won't stay lit. If I remove the cell switch and hold it down or bypass using a blade fuse, it lights and runs all day.
Do you have your exhaust port connected to your AFM furnace when you're testing this? Would be my first question. And we just came out with a video, Sid, 2-3 weeks ago? Yeah, where I demonstrated what these furnaces do when you pull the exhaust port out. So my first question back to you, it could be as simple as putting that exhaust port back in. That one actually stumped me for a while. I actually had to call Atwood. Now they're Dometic, because Dometic bought them. It's just like everything was testing out perfectly, but the thing would fire and then extinguish, fire and extinguish, fire and extinguish. And he's like, yeah, put the exhaust port in. And I did, and it worked just fine. So that would be my first question back to you. Are we verifying that the exhaust port is in the exhaust port? So that would be my first question. If it is, then we can take it to another couple things, but that's usually the easiest thing to check. So let us know if that exhaust port's in.
Okay, and then, yeah, you can feel free to put that in the chat and we can circle back. Okay, so not necessarily a troubleshooting question, but Sean wants to know, in the near future, would you be doing any solar system installs? I'm interested to see how mounting panels to the roof would go.
We've done quite a few solar installs. I don't know that I would do a video on it for several reasons. Every one of them is going to be a little different, and so I could spend all this time coming up with a 2, 3, 4 part solar install, and it's great, and you watch the whole thing, but it just doesn't apply to you. Better, what I would rather do is do a series on just getting your head wrapped around how to do a solar install, so that would arm you with what you need to know when you're going out there. So you had mentioned about mounting them to the roof. Well, do you have an EPDM roof? Do you have a fiberglass roof? And then you want to make sure what kind of fasteners you use. You want to kind of look at your roof to find out where the cross braces are. You would not want to just screw the solar panel to like the Luan decking that's up there. You really want to look around. You can get one of those little stud finders to find out where that cross brace is and make sure you're screwing it to that. Wind gets caught up on these things and wants to do an airplane lift on it, you know. So that would be, and sometimes you need to modify the mounting brackets a little bit where they attach to the solar panel if you're off by a little bit where your cross member is. Some of your RVs, their roof is a little bit thicker. They might go with a 1/2 inch plywood or something. So that's a little bit of a better grip. But once you penetrate the roof, you're going to want to seal that. Who is it? Dicor. The one I use is called Geosil. has an EPDM self-leveling product. I've used them all, but the GeoSil just seems to stay wider longer. I'll do a job and then we'll come back a couple years later to work on something else, and I'll look at the work that I did previously a couple years before. And the Dicor does great. It bonds, but it just kind of turns yellowish. And but I've done jobs where I use a GeoSil and it's still bright white. So for no other reason, I kind of like that a little bit better. I don't know. But yeah, you do want to seal it really well. When I'm sealing a roof, I'm visualizing on water. So the first thing you want to do when you're sealing that is you really want to make sure that the roof is clean, because sealant is not going to stick to a dirty roof. You're going to be sticking it to a dirt or something. So you really want to make sure that that's clean really well. I'll put some butyl tape under the foot of the solar panel and let that butyl tape kind of, it's like a tacky or a butyl tape, or I call it poo-poo tape. A lot in the trades call it poo-poo tape. So you put that under the foot, you screw it down, and then you would seal that around with a self-leveling sealant. Then you run your wires, and I like to put a fuse between the solar panel and my charge controller, because if there's a bolt of lightning or something like that set these things off, that bolt of lightning could take out your charge controller. So what size fuse would you use? Well, that's a function of the controller. That's a function of how many how large your solar array is up on the roof, and there's a math calculation. You can figure that out. And then I would fuse from the, so there's one set of fuses. I would do a fuse from the charger to the batteries. There's an arc. You just want to fuse all these different pieces so they're all islands within themselves that are protected from the fuses. And there's enough information out there to get the size of the fuse. There's enough information out there to get the size of your wire. There's enough information out there to wire your array either in a series or a series parallel configuration. Your mileage may vary. Already right now as I'm speaking, there's probably some people that are nodding their head yes and shaking their head no, because the thing that I found with solar specifically is there are so many different opinions, and I could have 5 people that I'm going to be talking to and they don't agree on whose is best or what procedure is best, or if it's better to go with series or better to go with parallel or better to wire them with a 48 volt. And so my approach is I let the customer do all of their research. And I even let the customer buy their own stuff. And then we just get hired to do the install. And I make sure that my installs are professional and accurate and clean. But I have done jobs where I've actually configured the entire system, done all the math for them and everything. And they've got the $1,000 Battleborn batteries and the fancy this and the fancy that, top of line everything. They go out there and they're trying to run their air conditioner and their TV for 3 days and it doesn't work and they get mad at me. And they're at a high latitude. Like up here in Washington, we're in a very high latitude during the middle of the winter. Forget about trying to charge your RV in the sun in the wintertime. It's just, you're only going to get like an hour or two. So anyway, for those reasons, I want the customer to be a little bit more involved in their designing of it. I'm there to help them consult on some of the best practices. But we could have discussion, which is better, a Ford, a Chevy, a Toyota, a Dodge, and everybody's going to have an opinion on that. And I would say it's even worse when I've worked with people on the solar side. But everybody seems to agree on the right way to do the installation, the hydraulic compression crimp tools and the shrink wraps and all that. So our focus as a business is to focus on the professional installation. And certainly we can be an advisor on what they might want to get. But I stay away from telling them, buy this company's because that company's. So anyway, I'm off the topic because you asked about securing them to the roof. For all these reasons, I think if I were to do a video, it would probably be over on our Academy side on some of the considerations and best practices you would do if you were going to do a solar install. But I don't know that I would put a solar install on my RV Works. So there's my short answer. So anyway.
All right, and that My RV Works Academy that he's talking about will be released sometime this year. If you're over on our Patreon side, you'll get kind of a first, well, you've already had a first look if you're over on our Patreon side, a teeny sneak peek, but we'll actually have content and a course available.
Yeah, and the RV Academy, what our vision is for that is some really deep dives where we're really going to go deep. If you're an RV tech and you need continuing education credits, that might be a thing where you can get some CEUs from the RV Tech Academy or from the My RV Works Academy. So we're developing that. But it's a passion project and it's just taking some time because there's just 2 or 3 of us that are actually doing it in the middle of everything else we got going on. So anyway.
All right, so I've got a few more shout outs.
Okay.
Candy is tuning in from Georgia.
That's another
Paul
Georgia.
from Omaha, Nebraska. Duck Spit PPG. It's interesting, some of your
Yes.
names. Raleigh, North Carolina.
Nice.
And thank you for letting everybody know. Yeah, thumbs up if you like this video, if you've learned
Sure, yeah.
something, or if you like this video so far. If
So
you've
far,
liked
yeah,
what
I
we've
might say
done.
something that's totally wrong, but anyway, yeah. You might still like it, yeah.
Yeah,
A
but
lot
if
of
you've
East
learned
Coast folks.
something,
Yeah, so it's late over there. So hey, thanks for staying up for us.
thanks for tuning in. And so he actually asks, I'm just assuming it's a he. New build, would you do diesel heater, propane, or mini split heat pump?
What kind of RV am I in?
Okay, so you answered that. What kind of RV?
I can tell you my favorites.
And then why don't we go circle back to Brian, because he does say exhaust port is connected.
Okay, exhaust port's connected. Okay, so the exhaust port's connected. Now tell me what it's doing.
Okay, so his question was, I have an Atwood furnace that I'm working on. Everything checks out good, but won't stay lit. If I remove the cell switch and hold it down or bypass it using a blade fuse, it lights and runs all day.
Okay. So you said it was an AFM, and so Atwood, it very well could be a sales switch. So we've assumed, okay, so your exhaust port's in, we talked about that. How you're going to know is if you take your meter, and I don't know if you're going to be able to get to the front of your furnace, but let's assume that you can. Sometimes they put an access door and you can get to it. But what you're going to want to do is take your meter, and if the furnace is flaming out, it's flaming out because it's not getting a signal, okay? So we need to take our meter, and I've done several other videos where there's one that we've done in the last month or two, maybe 3 months or whatever, and where I take my meter and I'm touching at different points to demonstrate following the trail, following the circuit, okay? And so if it's flaming out, it's going to be flaming out for a reason. So if your cell switch, if you suspect it's a cell switch, then you'll take your meter on your cell switch and you'll verify that the power is coming in from the high temperature switch, that it's coming in there, and then you'll move your meter down to the bottom part of the cell switch and you'll check it there. And so if the cell switch is having an issue, and there's a little asterisk thing here. Here, there's a one of these things. Okay. So you can check this at the board on the blue wire coming back to the control board. It's going to be the blue wire on your Atwoods. I think there's going to be 2 blue wires right next to each other. It's the one on the outboard side. The second blue wire in is the call for heat circuit, but it's the one on the next to it that's on the outboard side of that white connector. That's the one that is going to be coming from the sale switch. So in our test lead set, I've got the little pointy probe that you could stick in there and leave it in there and reference a ground signal. If your furnace is flaming out, because the cell switch, you're going to see your meter drop to 0 at that point, and then you know it's a cell switch. Now, what this is all about is when Atwood started to come out with their AF series furnaces, which is the AFL, S, and M for large, medium, and small, they had a hell of a time with cell switches. They really did. They went through 5 different redesigns on these cell switches, and I've got to stock all these different cell switches. Some of them look like a big spoon, some of them are long, some of them have an angle to them. And what we found is some of the cell switches test out fine on your meter, but and they make the click sound, but it wasn't passing the current. You could get voltage, but it wasn't passing the current, the correct amount of current through. Maybe because the contact points were bad. Who knows? I never took one apart. But we were called in several times when Atwood came out with a new AF, because back then we were an Atwood Authorized Service Center, so we got all these calls, and Atwood kept sending us like a case of sale switches because they knew they had problems. And then they changed them, so now I got to stock 2 part numbers. Then they changed them again, I got to stock 3 part numbers. So on several of these brand new furnaces, on a brand new RV, we would be called in and we would find out that this brand new furnace on a brand new sale switch, the sale switch was defective in some way. So it wouldn't surprise me if it was a sale switch. It wouldn't surprise me because you said it was an AFM Atwood furnace medium. So look for that. If you want to prove that that's the problem, then you would take your meter, look for the blue wire going into the control board, and you would see the voltage coming and going. Okay, so let us know if that helps at all. But because we've had so many problems with these new series, the Atwood's newest series, because they stopped doing the hydroflame, they came out with the AF series furnace, and we had a lot of problems with the cell switches. And then we had problems with the exhaust port. A lot of us were playing with these furnaces. We didn't know the exhaust port had to be plugged in, so now we know that. So that's the start. Is the furnace? They were having problems with their cell switches. Now, if you get a newer cell switch, one last thing: if you get a cell switch for that, do make sure that the sales switch you get matches a serial number series for that furnace, because they're all called AFMs with the numbers and everything, but it's a serial number where they would change. So I've got an AFM, serial number 1, serial number 100, serial number 1000. I might have 3 different sales switches all for that AFM, but the way you know which one works for yours is the serial number. So make sure you get the right sales switch for that series of serial number for that furnace. Okay.
Okay, and so regarding the new build, so
Yes.
the question again was diesel heater, propane, or mini split heat pump, and he says building an enclosed trailer 7x12 for PPG camping, powered paragliding,
Okay.
trying to go lightweight.
Okay. I didn't hear radiant floor in there. So if you go to Gold Heat, goldheat.com, what you're going to be looking for, if you want lightweight, I'm wondering if you're going to have electricity, because they have a carbon fiber film. It's like a giant roll of paper towels you just roll down. You put that down first, and then you put your flooring on top of that. And so the gold, I think that's called black heat. So the gold heat is a mesh, looks like a giant gauze with wire in it, and that's what you would put down if you were going to put ceramic tile or granite or, yeah, something. But if you're going to do like linoleum or wood flooring or something like that, they have a product called black heat, which is just like a laminated roll of, and it's got a carbon element in it, and you just roll that thing out. It weighs hardly nothing. And then you just get your little kit to crimp all your ends together, run it up to a thermostat, and run it through a GFCI and plug it in on 110, and your whole floor becomes your heater. So those are my favorite. They're the lightest weight. The only caveat to that is you have to have electricity. So then you talked about heat pump. Heat pump is great if you're going to have an air conditioner. Might as well get one with a heat pump. The challenge with a heat pump is if the ambient temperature outside gets to around 40 degrees, it's going to stop working, because there's not enough heat in the atmosphere at 40 for it actually to do work. On the heat pumps, they have a temperature sensor on the outside pan of the air conditioner. It's just like the refrigerator we were talking about. It's sending resistance value and ohms value to the control board. But if it drops below 40, your heat pump's not going to work. So then that would be a forced air furnace, like we were talking about with the Atwood, the Suburban, the Dometic furnaces. Great, they require propane and 12 volts battery. So they're fine, they're noisy, inefficient. Those types of furnaces, you're going to lose 40% of your heat just through the exhaust, so know that. If it's cold, you'll go through your regular 20-pound barbecue size cylinder every 3 or 4 days if it's cold and you're running it regularly. So then you talked about diesel burner, which I'm assuming is either going to be an ITR, Hurricane, or what's the other one? Oasis. ITR makes one, Aldi makes one. You see a lot of those in the Airstreams, or of course the AquaHot makes one. AquaHot now came out with one recently that runs on propane, so check that out. So you got a lot of options there. My favorite is the radiant flooring. Okay, it's the lightest weight. The only thing is you need to be able to plug it in to 120 volts. And so if you're going to be running a generator, great. Would it work on an inverter? Here's the thing. You're needing heat in the wintertime. Wintertime days are shorter, so you may not have enough sun to charge your batteries to run the inverter to charge your floor. So you would either need shore power or a generator to do that. So a couple options. Sounds like a fun build, but there's pros and cons to all these different things. The cheapest might be the furnace, and then going up would be the air conditioner would be next. Your radiant floor, it's not expensive to buy the parts. The expense is in buying the tools you need and in the install. But if you're doing it on yourself, you can save a lot on the install. But again, hands down, my favorite would be the radiant floor. Gold Heat, Black Heat would be a company that we've worked with before. They help you design it and send you everything as a kit. There's other companies out there, but the only one I've ever worked with was Gold Heat, or Gold Heat, Black Heat. It's the same company. It's just they have 2 different products, and maybe by now they have more than that. But anytime we ever did a linoleum or a wood floor, we would go with the Black Heat, and anytime we would do a granite floor, we would go with the Gold Heat. So hope that gave you some information to arm yourself with some ideas on how to keep that warm. Sounds like a fun project too, paragliding.
All right, so Ralph says Suburban SW60, direct
Water
spark,
heater.
no pilot light, and only gas, not dual.
Okay.
The water heater will ignite and warms up the water with no problem, but once it heats up and the burner shuts off, the igniter still keeps clicking.
Oh, fascinating.
We have counted up to 5 times and then we turn the water heater off at the main panel. The first RV shop advised it was the main board, which they replaced, but the next day we tried it and yet the same issue.
Okay.
The second shop advised it was the thermostat and possibly the igniter, so that was done, but still the same thing was happening.
Interesting. Okay.
I just replaced the regulator and pigtail hose plus the connector hose a week ago. That hasn't had a bearing on how the heater works, and my sniffer tool indicates we don't have any propane leaks. The only thing mechanical left is the gas valve and the attached solenoids and the control panel. Could one of these 3 items be the culprit?
Okay, so let me make sure I understand. So you've got a Suburban water heater, and it's gas only, not electric. And you flip your switch for hot water, and it lights right up, heats up the water just fine. And then now the water's at temperature, so you would think that the water heater would be fine, but from what I'm hearing, it continues to try to ignite.
Right.
After it's at temperature. That's interesting. And so I don't care what the shops did. So let's just take it from there. The way those work, okay, so here is your, on your Suburban water heaters, you have this thing about the size of a deck of cards. It's usually manila in color. And then it's got like this little connector where you have all your little white connector plugs into it. And over here you have your electrode wire coming out of it. Okay, so what we're gonna focus on that is the red wire. Okay, so we're gonna focus on the red wire that's feeding that. So you're going to have a ground reference wire. You're going to have a blue wire that's going to tell you that your light. You're going to have a couple wires coming out of here: a ground, a blue wire, a brown wire, and the red wire. Okay. So the red wire is the one that we need to focus on. Okay. So so here's your switch inside your RV, and it's going to come into your water heater. And here's your water heater. And then right here, you're going to have, it's these little things that you push the button in to either set or reset that ECO switch. And then your water heater, your Suburbans have a flame that shoots in there. So you're getting 12 volts coming into here. It goes through your switch that you human turned on. It's going to come into your water heater. And if we were to look at this device right here, I'm going to draw a bigger version of it. You have these 2 little tabs, just like a regular thermostat. You have a wire that connects them that's soldered. And so here comes the red wire. It's going to go onto a flag connector. This is your ECO. This is the one that's going to have that push button feature on it. And then it's going to go through this wire. And then this is your thermostat. Okay, it's on, off, on, off, on, off. It turns on at, it turns off at 140 degrees typically. And then it turns on again at 115. So this is going to be 140 to 115. Okay, you see I'm dyslexic, I did that wrong. So then this pin right here, I'm drawing this because I think this might be your problem. So it leaves this connector here and it goes into your DSI board, DSI, okay? So let's follow our circuit here. Okay, so you turn on your switch. It goes through 2 devices, your ECO, energy cutout. This one's going to trip at 180. Okay, this one's going to turn off at 140. Okay, so here comes 112 volts. Why? Because you turn the switch on. So 112 volts comes through. It goes through your energy cutout. Should be closed. This is the one that's got the push button on it. So when you push this little gland here on your cover, you're actually going to reset this at 180. Then this is soldered on. It's going to go through your thermostat, which is on, off, on, off, on, off, on, off, on, off, on, off, on, off all day long from 140 to 115. And when I have not 120, 12. When I have 12 volts going through my energy, that means I'm less than 180 degrees. Then I'm going to go through my thermostat. That means I'm less than 140. Then I'm going to go into my DSI board. Okay, so the DSI board then comes out on the brown wire. I'll make the brown wire black. So then it's going to come out on the brown wire, and it's going to go down here to your solenoids and all this kind of stuff, and open up the gas to let it go into the valve. So you're telling us that when you flip the switch, it starts. So the DSI board ignites opens up the gas valve. There's two things that are going. The first thing is I'm going to energize my dual gas valves, and the second thing I'm going to do is I'm going to start sending a spark down my electrode wire, which is going to end up over here. So I drew that because for us to understand what's going on, it sounds like you've been to a couple different shops and you're just throwing parts at this thing. But let's understand what this is doing. If it starts the first time, then we're through these two. It's colder than it needs to be. It's going. But if the water heater is satisfied, and that is to say it's between 140 and 115, that should be open. In other words, 12 volts is coming, it made it through here, and it stops. It's like, okay, there's no reason for me to send 12 volts to the DSI board to open the gas valve and send spark through my igniter. So what I would want to do is if I was diagnosing this and this thing was trying to ignite itself, that's why I told you about the red wire in the beginning of my story. I would take my meter. I want to know what's the status of this red wire. When my water heater is at temperature and I still have voltage on this red wire, the DSI board is going to do what this DSI board is sitting all by itself with nothing going on in its entire life until it gets 12 volts coming in on the red wire. As soon as 12 volt comes in on the red wire, it does what the DSI board does. It's assuming that everything's fine, and it's going to open the gas valve, and if it tries 3 times and it can't, then it's going to energize the blue wire. And the blue wire is going to go into your RV. Well, here, it's going to make a turn. It's going to go over by your switch and light up your light telling you have a DSI fault, direct spark ignition. It'll try 3 times, and after that, it'll turn the light on. I did it in blue because the wire leaving this is blue. So for us to figure out what's going on there, and for the shop to figure out what's going on there, they need to catch this when it's having this problem, and they need to verify, do I have 12 volts feeding my DSI board? If you have 12 volts feeding the DSI board, it's not the DSI board. The DSI board is doing what it's supposed to do. So I heard you say they replaced these things. And so if they replaced these things and it still did it, then I'm curious, did they put the right ones in maybe? Because that's a curious to me. Because in order to diagnose this, we have to follow the trail. If there's 12 volts on the red wire, you're off to the races. This is doing everything you're expecting it to do. Where does the 12 volts come from? It comes from this module. And this is usually on a plate. It's usually on a little plate here, and there's a little screw right here in the middle. Now, could it be the solenoids? Maybe, possibly. In other words, that is to say, we're trying to ignite and it's not. So could it be the solenoids? What I would ask you to do is, if you're doing this and it's ticking like crazy, do you smell gas down here? And so what you, human, could do is you could take the brown wire and you can just put 12 volts on the brown wire down here. You should smell LP gas. Because you're energizing, if you're putting 12 volts on this brown wire here, you've energized both solenoids and you're sniffing the LP gas. You should smell it pretty strong. If you don't smell gas, then yes, then at that point I would say you have a problem with one or both of your solenoids. They both need to work. So yeah, you might have a problem with your solenoids. I doubt it's a gas valve. We do have videos on this. There might be, the furnace and the water heater use the same type of a idea on this. So if you need the solenoids, you could go to our Amazon affiliate page. I do have the solenoid links on there. It's under water heaters and it's under furnace. There are 2 different types of solenoids. So anyway, that's my take on this. I like the idea that it could be the thermostat. The only reason I would suspect it's this is if I've got 12 volts going in and nothing's happening, then there's a problem here. Then I would look for my ground. I would make sure I have a good ground on this because I've got 12 volts coming in. And that's why when I check my 12 volts going into my DSI board, I want to reference the ground of the board, not the ground of the frame, because maybe this has lost its ground. So let's check this and reference the ground of the DSI board every time I'm doing it, because the frame's grounded and that's where your meter's grounded, but let's reference the ground of this because maybe the whole problem is the ground of this. So hope that helps. It could be one or both solenoids. The reason I'm thinking maybe not is because you say that it works and then it says it doesn't work. So if there was a problem with your solenoids, then I would think that it wouldn't work. And but if this thing's trying to tick, I like the idea of the thing, but you said they already replaced that. So hope this drawing helps make sense, but we're following the trail. You human turn on the switch. It goes through your ECO, goes through your thermostat, comes out and comes the red wire on your DSI board. It leaves the DSI board on your brown wire, opening up your redundant gas valves, and also does the ticky sound to ignite that. When these engage, you should smell LP. If you do not smell LP, then one or both of your solenoids are bad. I'm curious why it worked the first time and then it didn't after that. So, but it's still good to check those. We did a video, gosh, it was like a year or two ago, where go to our water heater playlist and I actually demonstrate how the solenoid works. I had my son with me and we energized a solenoid and it pulled a screwdriver inside. So we did a video where we demonstrated how all this works. So if you hang out on our playlist for water heaters, I know I've gone through all of this and then some. So hope that helps. The only other thing I would add is this is on the DC side. There's another one of these that looks just like it, but the pins are opposite, and the DC pins I think are small, skinny pins, and the AC side I think the pins are bigger, huskier pins, and they're not interchangeable. Those pins face this way, the DC pins face this way, so they're not interchangeable because then it'd be upside down and your push button would be wrong. They're spec, they're both 140, 115, and 180, but they're just designed backwards. So one's for 120 volts, which you do not have, but some of you may, and the other one's for DC side. Hope that all makes sense. So I'm going to erase all this.
Okay, and then Candy has a question. Candy, I don't think we're going to be able to tell you like the specific part number, like, yeah, we wouldn't be able to do that off the cuff, and we don't have like a dedicated parts department, but Darren might be able to give you some tips if you're looking for the access door. So her furnace wouldn't fire up, but she noticed that it fired every time she put her hand over the air intake, and so she figured out it was too much air input preventing the ignition. But she looked and saw that the air intact vent wasn't seated properly internally due to the screws on the door being stripped, and the furnace wasn't level. And so she needs to screw down the furnace box to the floor in order to level it and align the furnace with the access door. The screws that hold the cover on are stripped and cracked, and I believe I need to get a new access door frame.
Okay.
And so she's taken the measurement, she's got the part number, I'm trying to see if it's serial number or part number, it looks like part number, so serial number might help you.
Yeah.
And she said she doesn't need part anymore. So.
Okay.
Oh, good, okay. All right.
Good job in troubleshooting.
Yeah, that sounds fun. Yeah,
Yeah.
I like those puzzles.
Okay.
So what's the question? Or
I don't think there is one now.
Okay,
I think we're good to go.
I did do a video on one that had the stripped out, like the blower cover, the 4 screws that go in the corner, they were broken and stripped off, and I did a video on how I MacGyvered something in the field to make that stay closed. So under our furnace playlist, that one goes back 3-4 years ago. I don't even remember the name of it, but I remember where I was at, but it was a really older furnace. But yeah, we had to MacGyver something to make it work. So there's a tip there maybe.
Okay, and so John says, hey Darren, do you believe that the stabilizer holes work if you move them to the front? I have a 2012 Georgetown 360 motorhome on an F53 chassis.
Stabilizer holes on the front.
I think maybe a little more detail.
Like for leveling
what is that?
system. So but if this involves like leveling systems and installing those, I'm not going to be the guy. We diagnose them and we troubleshoot them, but as far as where to mount those, that would not be anything I'm going to want to try to field. Too much liability because it's in the wrong space and all this kind of stuff.
Okay.
But
We can go back to Candy because she just said
Oh.
still have intake problem and no firing.
okay, so what's going on with Candy's furnace?
Candy, if you can just kind of succinctly put it in, because that was a big email and it's kind of hard to keep all of that info, read it out loud and keep it in the head. So if you can kind of succinctly put your question, what the issue is, then we'll get back to it. And okay, you did put the Suburban. Okay, so we've got the model.
Okay. So it's a Suburban furnace?
Yeah.
Okay. And it's not igniting or it won't stay ignited?
Well, she says it fires every time I put my hand over the air intake.
Okay.
So that's kind of, I guess, the issue is if she puts her...
Okay, so what I would,
And
let's...
it's not firing. She says intake problems and not firing.
Okay, lot there, but talk to me about the exhaust, not the exhaust, but the ducts leaving the furnace. What we need to have on those furnaces, at least no less than four 4-inch ducts that feed the living space that can be returned back to the furnace. So if one of those ducts goes into the basement area to keep your tanks warm, that does not count. So we need 4 ducts. So what we need to do is, if you're flaming out, we need to make sure that you have good airflow, not only just coming in and going back out to the outside, but also within the coach. So if you have, we did one, gosh, a year and a half ago, where I took my borescope camera and that furnace exhaust dumped all of its heat down into like this little gasket, and then in the ducts in the floor. And we were having issues with it. It was flaming out all the time. And so I took my borescope, and what we found, it was a relatively new RV. And so all the ducts that they had put in, they had used foil tape. The foil tape had lost its adhesion. It wasn't sticky anymore. And so these ducts were all collapsed and compressed and everything. And so there was no good airflow through the floor, okay? And so the furnace was generating all this heat and moving all this air, and it just couldn't move the air. And so it was backing up inside of the furnace. So that's what I'm getting at. Now, if you have the ducts that kind of go on and screw, make sure that they're as straight as they can be. If it makes a turn, it's a nice, pretty turn. We did one, it was a relatively brand new RV, and these things are all spaghetti mangled all up inside of this thing, and the furnace kept flaming out. And so we straightened those things out, and it worked wonderfully. We've also done those where the manufacturer will take the 4-inch ducts and connect them to the furnace, and they'll run all these ducts down to one central distribution box in the floor and expect that to go. And what we found is they were fighting each other. So if you took, that is to say, if you took one of those ducts off the furnace and you're expecting the heat to be leaving the furnace going into the RV, and you took one of the ducts off, because the other ducts were all connected, we had a lot of air coming out of the duct back into the furnace. And so we're looking at, you're putting your hand over it, but let's look at the other end to make sure that the heat that the furnace is producing can go somewhere. So the other thing on the Suburban, you do, I think it's a 1/4 inch. I'm trying to remember what the spec is on your exhaust port. When you put your exhaust port in, it does need to go in a little bit into that little black, it's not plastic, if they were it needs to go in a little bit. And so if it's just barely touching, that could be a breach. And so look for that. I did a furnace where we were doing an annual service on a furnace, and I don't remember if it was right or wrong, but I took the exhaust off, and it needed, I don't remember if it was just right or if it needed to be changed. I just don't remember, but I remember discussing that in that video. That's like 2 or 3 years ago. So let's look for this from an air perspective, not only from where you're putting your hand over the exhaust on the outside, but let's make sure that the heat can go where it needs to go. We did do a job once. I was still at a dealership for a while, and the lady brought her RV in, and she was saying furnace problems, flaming out, and so we opened the RV up. It had the slide rooms, and I'll just finish the story real quick. And we never could find anything wrong with the furnace. She had 2 furnaces, never could find anything wrong with either of them. So we buttoned the RV back up. She took it home. She came back the next day really upset because of the same problem with her furnace. So we bring it in, open the slide rooms, everything's fine. Cannot find anything wrong with this thing at all. It ran all day great. So she sends it back home, comes back to us the next day, extremely upset. And I'm like, okay, look, don't touch anything. I'm coming to you. And what we found was she had these big rugs all over the floor that were covering all of her registers. And so the furnace is generating the heat, and I'm like, well, there's your problem. We moved the rugs off the floor, and the furnace worked just fine. So it could be that. So without going in any more detail, because I want to get to more questions, but look for that. Look at the airflow even on the inside to make sure that that the heat that it's generating has a free way to get out of the furnace.
All right.
Okay.
So we have all the questions that we can take. We'll get to a few more here, but just want to let you all know we're going to be finishing up right around 5:30, and then we are going to hop over to Pacific time. Then we're going to hop over to Patreon, and we'll do our exclusive live stream over there. So Ray says, I need to do some welding on the frame for shock bracket and other issues. My question is about the electrical, all the systems, including the Allison transmission module and other modules. Thoughts?
I have welded on frames. I don't feel comfortable answering that because of liability. if I say yes, do it, and then you mess up. So there's enough people that do this that would be better to ask. I'm a welder. I weld on frames all the time, but I'm not comfortable. You make sure you're grounded. Obviously, if you're welding, you know this. Your leads are the same length. You know this. You know all this. So I think your question is, you're going to hurt any of the engine modules, I think is what I would say. So I would say disconnect your battery, make everything electronic on your vehicle dead in the water, disconnect all your battery leads, house and chassis. So basically rig your RV for an EMP, So if there's an electromagnetic pulse that goes off, if that electronic device wasn't even connected, wasn't even on, it's immune to it. So disconnect all your batteries, disconnect everything totally, and then you should be okay. But I don't want to say that that's the answer. But that's what every time I weld on a frame, I'm always disconnecting all the power from everything. So if I don't want to create an arc on something and it messes something up. But if that thing was inert and it was just sitting there, a bunch of silicone, and it's not connected to anything, I don't see how that could be hurt from it. So.
All right. So Cabernet 2000 says, hi, are you getting asked to do lithium conversions for your clients? Have you done one for yourself? Have you fixed a lithium conversion electrical problem from a DIYer?
Yes, yes, and yes. Lithium seems to be the big thing that everybody's jumping to. The discussion I have with a lot of my customers is why they want to go lithium. And I'm really listening for one specific reason for the why, and that is because they want to go off grid for an extended period of time. These folks that are going to go from campground to campground, they're always going to be plugged into shore power. Why would you possibly go lithium? It just doesn't make sense to me. I would go to Costco and I'd get me golf cart deep cycle batteries that get water put in them if I was going to be at an RV park plugged in all the time. So some of these folks that want to go lithium, they want to save on the weight. Yeah, that's a valid reason, sure. But if you're going to invest that much into a lithium setup, I want to know why you want to do that. And where lithium has a lot of benefits to it, but for our industry, where it's really going to survive and thrive is you're going to go off grid for an extended period of time. It's just there's so many that you have to upgrade your charger. You have to upgrade. There's a module if you're going to have your alternator charge your batteries. There's just so many different things involved, and so I want to know why. If they're going to go into this thing, I want them to have done their homework a little bit on it. For me, I do off-grid camping, but it's usually for maybe 3 days at the most. I do wear a CPAP at night, and I just have 2 deep cycle golf cart batteries. I put distilled water in them. That's something I can service, and so I don't need the benefit of that. I'm not going weeks at a time, and so when we go camping, we've got a little pop-up camper. We love to just tag along and just go off-grid. Most of the campgrounds we go to are off-grid campgrounds. And so 2-3 days, that's really about all I can manage Darren personally. And so I don't see the justification, Darren personally, in putting lithium in my system. Just go to Costco, get 2 deep cycle golf cart batteries. I am good to go. I could probably go a week and a half on that. Every time we've camped, we've never had a problem with power. And it's not the lithium batteries. This is what Grandpa and Grandma used for years and years and years. It's good enough for me, right? So, but we have done a lot of the conversions for folks. We've put them under beds. We've put them all over the place. So it seems to be a pretty popular thing. Overwhelmingly, the folks that do that, I let them do all their own research. I referenced that a little bit earlier in the video. I don't want to be involved in which is better, a Ford, a Chevy, a Toyota, a Dodge. I don't want to be involved in that discussion. Everybody has an opinion on that. Everybody has an opinion on who manufactures the best and whose is best. I don't want to be involved in that, but I'll do the professional installation for you. I just don't want to be involved in what you pick. So I want you to make your own choice. So I don't know if I answered your question, but there's a market for it. And what I focus on is the professional installation. Therefore, I need to invest in the types of tools that we need to make the hydraulic compression crimps, the heat shrink and the heat shrink labeling tape. Make sure everything's labeled, make sure you have good strain reliefs, and so that's what I focus on. I focus on doing you come to me with all your parts, we lay it all out, we have a discussion, and I'm the one that can fish the wires up the wall, put your little display on the inside nice and pretty, and get all the wires where they need to go, your shunt, making sure it's wired correctly, that there's no stress on the wires. That's just as important as deciding what to do. and so we have had people that have put these things in and they couldn't figure out the shunt, they couldn't figure out different things. So that's where my education focuses on for me is making sure that I understand how it all gets connected together. We did one not too long ago, and the gentleman had watched a YouTube video, and you had to set the dip switches. And so a gentleman had watched a YouTube video, and he was sure that the dip switches needed to be this way. And so I looked in the spec manual, and I'm like, well, according to the amp hours of your battery and your controller, they should be set this other way. And so my background's in engineering, as a lot of you know, so I like to go to the spec. And it turns out that the dip switches were very differently set than what he watched on YouTube. But we do have a lot of people that watch YouTube, and I think it's great. You're watching it right now, and I've learned a lot from YouTube, and I think it's great. But you still need to go in with eyes wide open to know that you're doing it according to the specification, what the manufacturer is for your application. So we've cleaned up some of that as well. So there's that.
All right. So first, I just want to, over here in the Pacific Northwest, March 1st, it's 5:30 and it's not dark out.
And Sid and Trisha had an anniversary yesterday. They have a leap year anniversary, which is cool. So they celebrated their 2nd/8th anniversary.
Yep.
So happy anniversary, you guys.
Thank
So wish them a happy
you.
anniversry. Yes. Yes.
Okay, and so we've got Ashraf and Celine have one more question.
Sure.
Dometic RM2652.
Wait,
I've watched both of your
refrigerator. Okay.
videos, refrigerators that work on LP but not on electric, and refrigerator that works on electric but not on LP. But you don't have a video, I think, that deals with what if neither works. LP does ignite and electric is flowing.
Ah, okay.
I have tested my thermistor and it is working between the correct ohm readings.
Okay.
On LP, my pilot lights up and the boiler gets hot,
Okay.
but the freezer nor the fridge get cold at all.
Okay.
On electric, the freezer nor the refrigerator gets cold at all either.
Okay.
I have AC power as the indoor refrigerator light comes on when one opens the door.
Okay. Good.
The upper circuit seems to be operating, meaning both the auto light and the check light will light up depending on mode of operation.
Okay.
Fuses on lower board are okay.
Mm-hmm.
Fuse and breaker panel is okay.
Mm-hmm.
And let's see. Yeah, so what does it mean if the refrigerator is trying to light the pilot even though it is on shore power and LP is off? That was I don't know.
I understand
Those were
where
two
he's going
different,
with this.
yeah, okay.
I know where he's going with this.
Thanks.
I need to know if the refrigerator's in a slide room.
Okay, so if you want to go ahead and I think you guys
I'd
are
like to
still
know if the
on-
refrigerator's in a slide room, but let me go with this.
Okay.
It's only going to be one of two things. Okay, so let me just tell you. The first thing it could be is ventilation of the backside of your refrigerator. Okay, it could very well be that. The other thing is you have a blockage in your cooling unit. Okay, so ventilation of the backside. I do have several videos in our refrigerator playlist on how, I was going to draw a picture, but I've done it enough times. So let's just focus here on what your problem. It's only going to be one of two things. If your ventilation is not correct up the backside, so let's just do. Here's your refrigerator right here. Okay, here's your slide room, and here is the lower vent, and then here is the upper vent. Okay, so air wants to come in through here and go out. Okay, and so if you don't have any baffling and all this kind of stuff, then the air's lazy. It's going to take the path of least resistance. It's not going where it needs to go. On your refrigerator, I said it's one of two things, so we're focusing on the first thing it could be right here. So on the top of your refrigerator, you have these little fins there, and the air must go through those condenser fins. It must, and if it's not, then you're going to have performance issues as you're explaining. So you have to make sure, if you open up this top vent and you can take your eyeball and you can look down inside, you're going to have performance issues on your refrigerator as you're explaining. So what we need to do, and I know I've got a refrigerator, I've got a video on this, creating a flashing. You go to Harbor Freight, get yourself a little brake press where you could take a piece of flashing you got at the hardware store and bend it. I do a video on how I did that. You're going to want to attach that so that the air that comes in has to go through those fins, and then you put a flashing on the top. Okay, so if your refrigerator, now this is if it's in a slide room. If it is not in a slide room, same thing, guys. You need to make a good proper chimney. So here we have our fins, and then here is our exhaust, here's our roof, here's our thing. So we need to make sure that there's a baffle that's forcing that air to go through the fins. Okay, so if it's not going through the fins, I don't care how awesome your refrigerator is and how awesome all your components are, it's not shedding the heat off of that. Okay, so that's the first thing. The second thing it could be, so I'm going to move on to the next thing. So make sure you have a good chimney up your refrigerator. And I do have several videos on that, me putting them in, me talking about it, me drawing pictures. The next thing it could be is a blockage. Okay, so visualize this with me. You're going to open up your lower access hatch here. You're going to see the absorber vessel here. Here's your boiler, okay? And then you have this tube that comes out and goes up like that. And then you have, coming out the side here, you have these little fun little curlicue things, okay? That's the absorber vessel. This is the absorber vessel. This is the absorber. It's called the absorber, and that's the absorber vessel. So what you have in here is distilled water and ammonia. So here is your boiler, okay? So what I want you to feel for, you're going to have one of three configurations. Your refrigerator has been running for maybe an hour, and you need to do this when it's running. You could do it on electric or gas, it doesn't matter. So what I want you to do is I want you to feel the heat of that boiler. Put your hand on it, feel the heat of it. And then I want you to reach up inside and feel the heat of the absorber. They should be equal within 10 degrees. So if this is 100 degrees here, we want this to be about 100 degrees. This is after it's been running for a while. If you have that situation, your refrigerator is healthy and happy, you have good circulation through the whole thing, okay? Now, let's say it's been running for, so let's do this as boiler, and this is absorber, okay? This is absorber, this is boiler, okay? So if they're equal, we're good. If the boiler absorber, if the absorber is hotter than the boiler, that is to say, this is so hot, you can touch it. This is hot, the boiler is always going to be hot, but this is like super, super hot. You can't even touch it, it's really hot. Then you have a leak, we call that a leaker, L-E-A-K. That might be evidenced by some yellow sodium chromate that you might see down in here, this little yellow powdery stuff that you might show up. It's dissolvable in water, you could take some water and dissolve it, but if you have any yellow down here, what has happened is you've got a breach in your cooling unit. The hydrogen has left. Hydrogen's out of the building. And so you're boiling your ammonia into not a hydrogen environment. You're just boiling the heck out of your ammonia, and it's working its way around here, and it's just, it's not doing anything. So if you have a breach, you see yellow sodium chromate. If you don't see it, sometimes I've even seen the yellow sodium chromate in here, and you got to take the thing apart to see it. So it's not always there. It could be inside. But that's warm and that's hot. You have a leak. The other way is if the boiler is hot, but the absorber is not. So now we're going to touch these things. That's really hot, and that stays cold. Okay, so if that's a situation, then you have a blockage. Okay, B-L-O-C-K-A-G-E. Okay, a blockage, that means that as your cooling unit, as your ammonia is making its loop and it does all of its fancy things, it's got a blockage. It's not making it to where it needs to go. And typically what we find is I've saved several of these cooling units because we do a lot of cooling unit replacements. We just did one yesterday. We do a lot of these, and we work with a company, RV Cool, out of California. They're a great company to work for if you need a cooling unit, so I'm going to give them a shout out. He doesn't know I'm doing this. I'm not being paid, but we've done so much work with them that I'm so pleased with the work we're getting from RV Cool that I think Chris is doing a great job down there. So there you go. But we do so many, he doesn't, normally he would want them back, but we just did an Oracle 1200 yesterday. He doesn't want it back. He's like, there, we got enough. We don't need any more. Please don't pay the shipping to ship it back to us. So I have these, and I'm going to be slicing them open. And we're going to be cutting them open in different places and seeing what's inside. So that's going to be on our Patreon Academy side. I don't know if I'm going to do it for the YouTube side. I'm going to do that on the Patreon side. So that's another reason to join us over there. So typically what we find is you have the distilled water, the hydrogen, the ammonia, and the sodium chromate. The sodium chromate, this thing may have operated off level or something, and the sodium chromate starts to crystallize a little bit. And I'm going to try to cut up some of these things to see if we can find that, okay? And so what a lot of guys will say is turn your refrigerator upside down or bang on it with a hammer. And what that does is in your refrigerator, you got big loops and big pipes and small pipes, okay? And so this flake of toast is floating around inside of here and it gets lodged in something and causes a blockage. Banging on it with a hammer might free the blockage. Turning it upside down might free the blockage. it's going to come back, and the whole purpose of the sodium chromate in there is to act as an anti-rust inhibitor. So if the stuff's starting to crystallize and not be sodium chromate in solution anymore, then that means the ammonia is starting to get a little bit of an upper hand. And remember what the sodium chromate was in there for? To keep it from rusting the pipes. So now sodium chromate is not as strong as it used to be. The ammonia starts to get the upper hand. Now you have a leaker and you have a rupture. So if you have a leaker or a blockage, then replace the cooling unit. I love Cool Fun RV. We've been working with Chris for a couple of years now. They're doing a great job. So you either have a problem with your ventilation or you have a leaker or a blockage. So there you go. Has nothing to do with anything else.
Okay, so we are going to get to our last question, and before we do, I just want to let you know that we have tools for sale. We haven't talked about those in a while.
Gotta buy some tools.
And I just saw an order come through, so I thought, oh, I'll let you know. We have tap jigs, we have test leads, we have an AquaHot remote diagnostic switch.
Brake check tool.
We've got a brake check tool. We've got cool little cards that go with the AquaHot remote diagnostic switch. Yeah, so the test procedures on there. We have some merch. So head on over to our store and take a look. Okay, so Emily says she has a carrier error. She says, my issue was in the AC itself in the board. My furnace would not shut off, and I traced the issue to the AC board.
Okay.
The thermostat wires and furnace are good. I can't tell which board in the AC is at fault.
Okay, you have a carrier air conditioner. Those stopped being made and supported back in 2010, 2009. So you're not going to find any parts for that. So if you just want your furnace to work, I don't know. Okay, so you can go two paths, and I know we're at the end. So so if you've got a carrier air conditioner, I have an RV with 3 of them on it, and I love the Carrier air conditioners, and I'm just crossing my fingers that they never die because they're wonderful air conditioners, and I love that Carrier was involved. But I think during 2008 they just needed to trim the fat, and the RV air conditioners that they made for Carrier for the RVs, they said we're not doing this anymore. So good luck trying to find some parts for those. They do have that emergency heat button you can press. So, but if you've traced out your furnace wires, my recommendation would be let's just ensure our success and install a dedicated furnace thermostat on the wall. I do plan on making a video of this. I just don't know when I'm going to get around to it. But I've got an air conditioner that I know has got a problem, but we don't need air conditioners up here. But I did need my thermostat, so I put a Sensi, which is like your Nest or whatever. So it's Sensi. And it's kind of cool. So I've got 3 RVs with the Sensi in all 3 of them. And so from right here on my phone, I can turn them on and off and put them on a program. And so that's kind of fun. And so what that is to say is I'm not going through my air conditioner. I'm going directly to the Sensi. So this could have also been a Nest. So here I'm at 53 degrees in one of my RVs, 66 in the other RV. And this one, I know the batteries are dead. So RV heat there. And I can turn my heat on in my office. So I've got an RV that I've turned into my office. And so from here, I just turn the heat on. So I'm going to turn it back off because I'm not there. I'm about an hour away. So Sensi's kind of fun. That could also be the Nest. It could be all kinds of things. So the challenge with those is they live at 24 volts AC and your furnace lives at 12 volts DC. So you just use a relay. It's not a problem. I can help you guys get through all that. I've done it many times. Short of that, Honeywell makes one that's not programmable. It's just it just mounts on there. 2 wires come in from the furnace and they make a connection. And the challenge with installing those, on our Amazon affiliate link, I've got that thermostat under the furnaces. I think it's like $26, $30 for that thermostat. The challenge with those is knowing where to land your wires. And so if you do get stuck on that, I might have something like that in our manual section. But if you get stuck on that, I do hope to do some more work on that. I know that one of them was a C and one of them is a W. Anyway, there's a lot of these letters on the back of the thing. Like, which one do you connect to? So I've cracked the code. And there's a way to make those simple, dedicated $26 Honeywell thermostat work. Just 2 wires feeding it. It works great. Or you can go all the way up to the Nest or the Sensi. I went with Sensi because it was cheaper. And you can do this Wi-Fi furnace thing. So, and all this to say is just you're going to control your furnace not through your Carrier a lot of the times the carrier had this little remote control thing. So you're not going to be controlling your furnace from your carrier anymore. It's going to have its own dedicated thermostat.
Okay. So, yeah, Emily, I know you do a lot of work on your own, and I don't know if you've ever considered maybe you could start a YouTube channel, because it seems like you do, a
We need
lot
more
of work
YouTubers.
on your RV, and I think you had done some. I think she was the one that like had done some really creative work with like building a box.
Oh, I remember that. Yeah.
Yeah. So, we are running out of time. We do have commitments, and so we do need to
okay.
jet out. But I don't know. She said that she has access to parts, both boards available, and she just wants to diagnose the existing board. So I don't know if you have anything to add to that, and then we'll kind of conclude.
On the existing board, you're looking for the carrier to give you a dry contact closure. So you would take your meter in continuity mode, put it in the 2 ports where your furnace leads come up, and tell the thermostat to turn on heat. You should get a beep because it's a dry contact closure. The wires that come up from your furnace that would connect to that board, you touch them together, just the 2 wires together, your furnace should start. So here I am up in the ceiling. I've got the 2 wires I've identified that go to my furnace. I touch those 2 wires together, me human, the furnace should start. Great, I know my wire's good, it hasn't been chewed by a rodent. And then, great, so now I know that the wiring is good from my ceiling plenum down to the furnace. And now I need to find out if my the air conditioner is good. In that regard, I take my meter, put it in continuity mode, which is a beep mode, touch my 2 leads together, beep, 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 okay. So stick them in where the pins would go for my furnace, tell the furnace to call for heat, and I should get a beep. That means that that part's right. And then if that's good, guess what? You connect your 2 wires that you have identified as your furnace wires, you touch together, make your furnace wire, you connect them in, it should work just fine. So if it doesn't, then there's something else wrong. But yeah, continuity test on your air conditioner board and touch your wires together on your furnace wires, and it's really that simple.
All right, thank you. And so right now we are going to head over to Patreon. I know we still have some questions, and some of them are good questions. I'm sorry we can't get to them all. But if you're interested, you can join us over on Patreon for as little as $5. Actually, if you just want to know when we're releasing brand new content, you can hop over there and join for free. But at the $5 level, you get just a little bit of benefits. It's more just like a thank you at that $5 tier. But at the $15 and the $25 tier, then you get access to weekly content. At the $25 tier, yeah, that you get access to 2 Zoom calls a month. So hopefully you'll consider joining us over there. Check out our tools. I posted a link on that. And thank you for joining us. We hope to see you next month. Yes. We do our live streams every month, the first Friday of the month at 4:30 p.m. Pacific time. So we look forward to seeing you.
Where it's still daylight.
I know, it's so exciting.
Wait till summer. It'll be 10:30 at night and we still
dark.
got light outside. Our wintertime it's worse. At 4:30 it's dark, but in the summertime it's 10:30 it's still light. That's living up at the high latitude. It's kind of cool. On a peninsula. Yes.
Thanks for joining us.
Okay,
Have
guys.
a good night.
Bye.
Bye.
Bye. All right, let me go run to the restroom and then
That's
I'll...
fine. I couldn't wait any longer. I was like, you said you were going to end it at 5:30. I was like, okay. And I was